Imagine holding something that weighs 100 kilograms in your hands, heavy, substantial, real. Now imagine that same object suddenly weighing only 50 kilograms, and you haven't removed a single piece of it. The solid matter remains untouched, unchanged, identical. Yet somehow, impossibly, half the weight has vanished into thin air. This isn't magic. This isn't a trick. This is mathematics revealing one of its most disturbing secrets, a place where our intuition doesn't just fail us, it betrays us completely. Picture 100 kilograms of potatoes sitting before you. Ordinary potatoes. Nothing special, nothing mystical. But these potatoes harbor a hidden truth that will shatter everything you think you know about numbers. These potatoes are 99% water, nearly pure liquid wrapped in the thinnest shell of solid matter. Only 1% of their entire being is actually potato. The rest, just water, waiting. Now comes the moment that changes everything. You place them in the sun. Time passes, the sun beats down. Water evaporates, molecule by molecule, disappearing into the atmosphere. The potatoes shrink slightly, their surfaces wrinkling, concentrating. When you measure them again, they're now 98% water instead of 99%. A single percentage point. One tiny number on a scale. Surely this means they've lost almost nothing. Maybe they weigh 99 kilograms now, perhaps 98? But mathematics has been watching, and mathematics has other plans. The potatoes now weigh exactly 50 kilograms, half. Gone, vanished. But how? The solid potato matter hasn't changed. It's still exactly 1 kilogram of actual potato, just as it always was. No potato disappeared, no solid matter evaporated. The physical substance you could hold and eat remains identical. Yet the scale doesn't lie. 50 kilograms. Here's what happened in the shadow realm of percentages. Originally, 1 kilogram of solid potato represented 1% of the total 100 kilogram mass. The remaining 99 kilograms was water, pure, weightless-seeming water that we almost forgot was there. But when the water content dropped to 98%, that same 1 kilogram of solid matter suddenly represented 2% of the total weight. Not because the potato changed, but because the relationship changed. The proportions shifted in a way that defies human intuition. If 1 kilogram now equals 2% of the total weight, then mathematical law demands the total weight be 50 kilograms. Because 1 is 2% of 50. The water didn't just evaporate, it took half the universe with it. This isn't really about potatoes. This is about the moment when we realize that our most basic assumptions about reality can be completely, catastrophically wrong. A change from 99% to 98% water. It sounds trivial, meaningless, barely worth noticing. Yet it represents a loss of 49 kilograms, nearly half of everything. In our world of percentages and proportions, the tiniest shifts can trigger avalanches. What seems like a minor adjustment can restructure the entire foundation of truth. The comfortable math we thought we understood reveals itself as a house of mirrors, where nothing is quite what it appears to be. The potato paradox forces us to confront an uncomfortable question. If we can be so completely wrong about something as simple as potatoes and water, what else are we wrong about? How many times do we see a small percentage change in statistics, in science, in life, and dismiss it as insignificant? How many times does our intuition guide us toward answers that feel right but are mathematically catastrophic? The potatoes sit there, lighter now, carrying the weight of this revelation. They've shown us that mathematics isn't just a tool, it's a mirror that reflects the limitations of human understanding. And sometimes, what we see in that mirror is the realization that we never truly understood the weight of our own assumptions. So, the next time someone presents you with percentages, with proportions, with seemingly small changes in complex systems, will you trust your instincts? Or will you remember the potatoes that lost half their weight by becoming just 1% more solid? The numbers are watching, and they're not always on our side.